In this video, we're going to have a look at how we can organize the data that we've collected so that we can start analyzing it. Sometimes the amount of data that you collected can be overwhelming, and that is where organizing the data comes in. The better organized your data is, the easier it is to do calculations and then, of course, interpret the data. It is very important to order your data. If your data set is small, this is quite straightforward, but for large numbers of data values, we can make use of frequency tables or stem and leaf diagrams to help you to order the data. Example 1. A group of learners were asked how many siblings they have, and the data is given below. Complete the frequency table for the data. This data has not been ordered yet, but as soon as we've completed the frequency table, it will automatically be ordered from smallest to biggest. The frequency table consists of 3 columns. The first is the number of siblings, which indicates the different data values, from our smallest value of 0 siblings to our biggest value of 5. The next 2 columns have to be completed, and we start off with our tally column, which is literally counting how many of each data value we see in the data. So how many zeros, ones, twos, etc. The frequency then shows us the total of each tally. So it shows how many times that specific value occurs in the set of data. If we get started, the first data value is a 1, so we add a dash or a line to the 1 row. Next we have a 3, so a dash is added next to the 3. Then we have another 1, so we add another line. We continue with our next one, which is a 0, and then we have another 1. And continuing like this, my next one will be the 5th one. The 5th one, we add a horizontal line through the first 4. So this is a very easy way to indicate 5. And when we get to adding them up to get the frequency, it's easy because you can simply count in 5s. Once we've ordered all the data into our tally column, we can add up or get the total of each row in this column, and that will give us the frequency. For 0, the tally total is 3, which means 3 of the learners do not have a sibling. For 1, we have a full group of 5 and then another 4, so 9 learners have 1 sibling. 3 learners have 2 siblings and 3 have 3 siblings. There's 1 learner with 4 siblings and also 1 learner with 5 siblings. And if we now get the total of our frequency column, we know exactly how many learners formed part of the data. So here we have 3 plus 9 is 12, plus 3 is 15, plus another 3 is 18, plus 1 is 19, and another 1 is 20. So that means that 20 learners were asked this question. If we were given the frequency table and asked to write down the raw data, meaning working backwards, we would start with the 3. That means we will start with the first 3 values being 0. Next up, we would have 9 ones, and then you will continue like that, and at the end, you'll have 20 data values. Example 2. The number of liters of fuel that drivers put into their cars at a petrol station on a particular day is recorded below. First question, complete the frequency table for the data. This is a very wide range of data, as our smallest number of liters is 18, and the biggest is 54. To now set up a frequency table consisting from all the values from 18 to 54 will not make sense. And that is when we start making use of class intervals, which means we will organize the data into groups. Our first group or class interval is from 0 to 10. And this notation indicates that 0 is not included or not part of this interval, and the equal added to the second inequality means that 10 is part of this group. Any number of liters just more than 0 and right up to exactly 10 liters will fall into the first class interval. all the class intervals are the same size. So our second group is from just more than 10 up to exactly 20. This continues up to our last interval, which is just more than 50, right up to exactly 60 liters. This frequency table will be completed by placing every set of data into the correct class interval. Our first value is 30, and 30 is included or part of the third class interval, where I will go and make my first dash. Next up we have 45, which is in the second last class interval, and next up we have 20 falling in the second class. And you continue like this until all the values are sorted according to class interval. Now we can complete the frequency column, and in the first class interval we add 0 data values, then 2, 3, 8, 8 and 4. The total of our frequency column is 25, and this indicates that the number of liters of 25 drivers were recorded. Question B. Draw a stem and leaf diagram to order the data. A stem and leaf diagram also orders the data from smallest to biggest, but it distinguishes between the tens and the units. On the left of our diagram we have the tens, and on the right the units. So to place my first value of 30 in this diagram, at my tens on the left I'm going to 30, and the unit value will be a 0. Next up we have 45, so on the left with my tens I move to 40 or 4, and the units here will be 5. Next up, next to my 2, I will add a 0 for 20, and then we have 48. So after the 5 in the units of 40, I'm going to add an 8, and this will indicate 48. And then you continue adding the units value of every single data value on the right. Once this is done, all that's left for you to do is to arrange the unit side of every row from smallest to biggest. For the tens we only have 8, but for 20s we have a 0, then a 6, and then a 7. For 3s or 30 we have a 0, then a 2, a 3, a 6, 2 7s, and a 9. And then we do the same for the 40s and the 50s. And here we have our final stem and leaf diagram. And now it's easy to see that the smallest data value is 18 and the biggest is 55. In the next video, we'll have a look at what calculations we can do with this organized data.